Today I'm going to discuss about MCP, what is MCP and how it is working. Today we are going to go to the depths of MCP and we are going to try and create our own MCP server and use it through a Streamlit app. It's a unique app. It's a basic app, but like it is very helpful. So okay, so what is MCP? MCP is a standardized plug and play system. It was introduced by Anthropic in late 2024 for all the AI models. Now, it changes how we provide the context to the LLMs. Like first, there were only LLMs, like you can say GPT when it was launched. They were just pre-trained models, pre-trained decoder models, and they were having the massive data set of the entire internet, the books, and everything. So what happened is, whatever prompts which we gave there, it just rearranged those data and then gave it as the output. So it was not quite good and not quite intelligent, because the context which we gave, it only generated output based on what it was trained on, and the AI is only as good as the context you give it. So then when context came into picture, like when LLMs were able to be up to date with the web browsing, so when web browsing came, LLMs became much more valuable, and many people started using it. First, people were just using it for drafting their emails and all, but now they are using it for researching different research papers, researching videos, images, texts, entire files, and everything. So the context which we provide to the LLMs gave the LLM a superpower. Like they became much more valuable, and then further, as it grew, there was a huge integration mess. Like for example, let's again see what LLM is, like what MCP is. So the host, which is having the LLM, it is communicating with the servers. Like what is MCP? MCP is a client server architecture model where the host is communicating with its servers, and the servers are having a special language to communicate with the APIs, the different APIs, tools, and resources. So this is what MCP is, and they communicate through a protocol. And coming back to what happened is, as the system grew, we need more APIs now for integration, and different APIs and different tools, resources such as Slack. I want to integrate Slack. I have to go to their documentation and see how to integrate their API. If I want to integrate RoboFlow, I have to go to the RoboFlow website. I have to see each and every step and then put it in my code. So there are different tools and services. If I want to use all of that in integration, I have to use MCP, because MCP was created to solve this problem of the integration mess it created. So it communicates, the client communicates with the servers through a protocol which is known as JSON RPC protocol. So what happens is, client and servers are communicating with each other while maintaining the context. Like it remembers what you said. LLM remembers what you said. So the remembrance is done by JSON RPC. Like this is a protocol which it uses for remembering it, and that's why it is called as a stateful session, and it communicates through JSON, like requests and response it gets. It communicates through JSON. So that it has a well-defined life cycle of initialization, operation, and shutdown. So you can compare it with the rest, but there are some differences. See, this is how the protocol works. Like, this is a basic example. Like, a client makes a function of adding 2 and 3. It gives out the request through JSON RPC, and this is the format which it uses. JSON RPC, there is a method, there are parameters what to add, A and B. So there are two numbers to add, and it has given one ID, and the server replies it with the answer. So this is how like the JSON RPC works. Let's see the similarities between APIs, LSPs, and MCPs. They all are standard protocols. So LSP, like let's start from APIs. APIs are standardizing how web applications are interacting with the backend. And see, they are integrating with servers, the databases, and different services which we are able to use. So APIs enable us to work with the database, work with anything which we want. Like, they are facilitating us to use a huge amount of data on our data set or for a specific purpose. And then comes LSP. LSP is language protocol. What is the language protocol? Language protocol is for use for auto text completion, and you might have seen used VS Code. So in VS Code there is a tool of auto completion, auto generation. It predicts something beforehand. It diagnoses your code. If there is an indentation error, it throws out or it marks a red line, a blue, yellow line, and a red line. So that is what is used. It's been done by the LSP. It's a protocol. So it works on the language specific tools inside the IDEs, inside the editors, code editors. And then comes the MCP. It standardizes the AI application and its interaction with the external environment, the resources it uses, the tools it uses. Without MCP, this is what any application might look like. Like, we have to do custom implementation, we have to write our own prompt logic. For calling the tools, we have to write a custom code and everything custom. And it is like there are different chargers for charging different phones. So with MCP, everything is organized. So for accessing the database, we just create an MCP server and keeping the MCP client the same. So the databases are contacted by the MCP server, then CRM systems could be managed, then version control could be managed. So entire thing is managed by the servers and controlled by the client. So this is what APIs are like. If I were to draw some similarity between the REST API and the RESTful API and the MCP which we are discussing, this also follows a client server architecture. But the thing is, the API works in single direction. Like, the RESTful particular, the REST API works in single direction. Like, if we give a GET request, if we give a POST request, a PUT request for updating, for deleting something to the server, it will just do it. It won't remember the past actions which the user gave through the client to the server. So if it works in a RESTful state, then it is a RESTful state. But REST itself is not RESTful, it's stateless. And these are what the differences. Like, MCP has the client and server, but it has resources and tools. Only these two things. So it works with these two, while for individual querying and for getting some URLs, the REST communicates with URLs, HTTPs, so with the server. So this is what is the main difference. Like, while the MCP uses resources as well as the tools, you can consider MCP servers as the wrapper around APIs to get the services. So the wrapper around the APIs is the MCP server. Now let's see, we were discussing that there are LLMs and tools. and the problem is solved, right? But still there is it is like a standard and cross and problem. Like there are n applications, they are trying to talk with n various tools and databases. So every connection which we are making with that n number of tools are custom. And for connecting different applications and tools, I have to go through entire documentation of theirs and then see if there are no dependency errors between them, and then my app will work. So if you connect a local file system, you have to take a different approach. Now this is a fragmented chaotic mess that developers don't like. So Anthropic came into picture and it created this protocol. So it is like a USB-C protocol that any phone or any charger could connect to any phone. So if the phone has a USB-C type, so it is giving a predefined set of rules. Model context protocol. So model is anything, any model like Gemini, Claude, GPT-5, anything. And context is the code from your repo or database or files or whatever information you give to the large language model to make it smarter. It is like responsible for making the LLMs more context aware. That is what context is, and protocol is what we discussed right now. It's a standardized full book, and it guides the model how to ask and receive the information, just like it's the HTTP for the websites. This is the diagrammatic representation, and MCP has this bidirectional data flow where AI applications are interacting with the resources and tools, and the tools and resources are interacting with the AI applications. So the protocol between those is connected through MCP. So there are different sources, remote as well as local. For local, we have databases, files, and personal APIs. And for remote, if you want to connect a Git API, we want to update our GitHub. We want to clone some repo or push some code which we have done. We can just prompt it by just connecting our MCP server through GitHub API, and we can just prompt it on our client that push my code, so it will instantly push it. These are the available MCP clients: Cursor, GPT, Claude, Desktop. These are the popular ones, and these are the frameworks. So Composio, Agno, Prison, and LangChain. So these are different frameworks, and Composio offers a library that has many MCP servers which we can connect with our client. So if we want some task specific server, we can search in Composio. Now let's see like what are the integrated platforms. So Cloudflare, Supabase, Microsoft, GitHub, everyone has their own MCP servers and their implementations. So if we want to use anything, we can just take their APIs and see its documentation. See what is the architecture. The key concepts are hosts and clients. So client here, the first layer is the host layer where the AI application sits. The Claude, GPT, anything is the MCP client. So it is connected with the server. It is a local server, it is a database. Then if it's a remote server, then it could be anything, any tool you desire. This is a simpler version. So the prompts, the resources, the tools, everything are there inside the server, which is being there is a bidirectional flow between the client and the server, and the client can also act as a server, and it can happen vice versa. So a client is also a server, and a server is also a client. You can see that because whatever output which I am getting from a particular client, that I can use for as a input to another server, and then whatever output that server gives out, that would be acting as a client. So it can be bidirectional. So this is what is unique in MCP. So let's build our own MCP server. These are the steps which we will follow. So I have already followed these steps. First, I've created a virtual environment, and let me explain you what the server is. We are creating a uh, a question, like we want the highest number of the frequency of the questions which are being asked in previous year question papers. So we are making a student um, question paper retrieving system where if we upload our question paper, we are going to get the most number of the frequency, the questions which were asked the most in that particular year, or in a few years, if you want to just track it, like which questions were asked the most in that year. So we can get those information using this server. So I have implemented a rack pipeline here also. So using MCP server, we are creating the client. The client is our Streamlit app, and we are giving inputs in through the client. Basically, the main thing here is the server, and the server which we have made consists of different tools. One tool for extracting questions, another tool for storing it in the vector database, then another tool for getting the most asked questions and analyzing the questions, and another tool for sending research to Slack. So this was the entire flow diagram of the server, MCP server. Now we have seen the theory part. Now let's proceed ahead and let's build our own MCP server.